Welcome back. I'm sure you are enjoying the reading and learning a lot about this embedded system on ARM Cortex M4. Today is day 29. If you haven't revised the previous days and previous details about ARM Cortex M4, please do so by going back and looking through all of that and try to get everything out of it so you would be able to get everything and you can create your own project. Today we're going to see one of the project. Yes, in the last session you have learned the Bluetooth based home automation project. In this second major project you're going to learn about data monitoring using STM32F411, but you're going to monitor the data and send that to the cloud. We're going to use ThinkSpeak, which you will find it really interesting, and with all of this you can come up with your own project in the end. In today's section we're going to cover an IoT based data monitoring system using ARM Cortex M4, and today you're going to learn another concept using a Wi-Fi board. Yes, you're going to transmit these data through a Wi-Fi module, and that Wi-Fi module is ESP8266, and you're going to link that to the ThinkSpeak cloud. So whatever you send through the data, and we're going to use an USART as well, whatever you send through the data you will see in the ThinkSpeak cloud, which you will see in the later slides, but that's what you're going to learn today. About A2Digi, I'm representing A2Digi. As you know by now, it's a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered over 20 plus years industrial experience, and we would really like to put it out there so that it will all help you to build your career and also being successful like we are. And our mission is to convey our knowledge to at least 100,000 future and upcoming professionals through our online courses. The good thing about this is you can study at your own pace, at your own time, wherever you are. So that is really good about that. A little bit about me. I am Arul P. Anbukarasu. You can call me as Arul or API, as persistent as I would like to be, to share my experience and my knowledge to you all so that it will all help you to being a successful engineer. I have 20 plus years of experience working in various industries in Australia, in Italy, in Singapore, and in India, working in all these industries in renewable energy sector, converting solar and wind power, power systems that's connected to lead acid batteries, network embedded systems that's connected with the ATMs, TCRs and POS, banking automation systems, and smart parking operations. My expertise heavily lies on these three major department, or anything you can coin your word into. It's embedded systems, VLSI, and project management. A small announcement to make, as usual, all the videos that's been linked with the course will be uploaded in my YouTube channel, and to get a free certificate you have to attend at least 28 classes, and due to YouTube regulations videos won't live there forever, it has to be removed. So unfortunately, if you want to go back and revise, you won't be able to. So that's why I strongly advise you and recommend you to please join one of our internship program. And what would the internship professionals will get? They will acquire an internship certificate. Plus, using our learning management system with your own dedicated login, you can go through each and every day's session, and once you complete one session, click on marked, and that will count as your attendance. Not only that, when you compare this to your other fellow colleagues or even your classmates, when you land into that first job or you are on the interview, this learning curve sits on the top of everyone else, because you went there and you did that hard yaka and put all into it, and you know now on your hand and on your mind that you are comfortable and you are confident to build your own project, your own design, and that's a big plus in the industry. The senior engineers and the product design engineers will love you forever for that, because it reduces their time. They don't have to train you as hard as if you haven't had any experience. This 30 days, it's really a good example for them. Not only that, you will get on access, unlimited access to all the course contents. That means all the course videos as well, and all the source codes. If you want to pause your video and go back and do something and come back to do revise, you can do so. It's all yours to keep. And if you get stuck anywhere in the middle, please do contact our backend support team, and they would be able to assist you in your learning curve. Shall we get into learn what is this all about in the cloud to monitor data? Yes, you're going to link that, and you're going to soon learn how to do that. First, to start off with, what is IoT? Most of you would be by now, IoT abbreviates to Internet of Things. It is nothing but whatever you are connected and linked with the embedded with electronics, and whatever that you convey that to a sensor, and doing so by a software, and if you do that so by an interaction with an internet connection, and collecting all that and exchanging data. In a nutshell, all this is coined as an Internet of Things. Simply saying, interfacing with sensors and sending the data to somewhere with the help of an internet, and that's what it's Internet of Things. For example, you can do a automation thing at your home to link your electricity bill or your security systems, and you can monitor that through an app. So that's an IoT. Or in automotive, for example, shown in the diagram, you can monitor the speed accordingly, and also you can monitor the fuel level, etc. So these are all some of the examples which I just posted a couple of photos there, but this is just a start. You can come up with your own unique project. So this is simply as IoT. So these are all the hardware requirements to go along to yourselves to experiment all of that. Of course, you need the mother of all, the STM32F411RE board, a logic analyzer, ESP8266 Wi-Fi module, a small port, can be 5K or 10K, and an account with ThinkSpeak for IT projects, which I'll show you later how you can do all of that. But if you have all of this, then you are pretty much ready to go and explore yourselves with my coach in this session. In the software requirements, you already have the STM Cube ID, and I'm sure most of you will have the logic analyzer by now. The new thing that you need is you need to go to Google and type in ThinkSpeak Cloud, and you need to open that URL and then create a account for yourselves. And it is a free open source. You can create an account. So these three are the software requirements to learn about this project. Okay, being a new topic, ThinkSpeak, I would like to introduce and give you a little bit about ThinkSpeak. What is ThinkSpeak? ThinkSpeak is an IoT platform that uses your data to analyze whatever data that may be, whatever sensor that it's coming from. It will start to collect all those data and list up with the things that you talk about. Just to make it as easy, whatever things, like it can be a temperature sensor, and it can be something you're monitoring, a data monitor. So that's why they coined the term maybe things and peak. Likewise, so you can analyze the data, and if you go to ThinkSpeak, there are about 60,000 users who actively use this software on a daily basis. It also helps you to give you data visually analyzed as well, and also on top of that, there is a platform that's linked with MATLAB, which allows you to do more data analysis. And also, by visualizing and linking to MATLAB, you have things in front of you, and that makes you to act on something. For example, if you want to control your cooling system at your home, and by analyzing the data, if it is too hot, and when you go home, if you want to reduce into a bearable temperature, you can do so. So that's why you act on it. So sending between those signals through an IoT, through a Wi-Fi, it's all collectively, you can be doing that in ThingSpeak. So ThingSpeak is nothing but it collects all data from all the streams and analyzes the data, and you can visualize it as well. That makes you to take decisions about what you see and what you have to do. So that's ThingSpeak. Now let's talk about the project schematic design. As you know, we're going to use the USART 1 as well here. USART 1, as you know, if you go to that functional mapping that we've been talking about in the previous sessions, if not, please go back to the referral. It is in one of the reference manual, and it is there. If you want to go there, you will see that there. PB6 is connected to TX, PB7 is connected to RX, which is the same thing that's connected to Bluetooth via the TX. Yes, the Wi-Fi module has built-in Bluetooth as well, and the relay is connected to PA5. Whereas the relay, in this sense, you may be able to connect to the relay, or you can directly connect that to any GPIO. But in this example, it's connected to a relay, but you don't have to do that. You can also do a different schematic design. And by default, you'll get all the Bluetooth settings. And this is the block diagram, IoT block diagram. So you're going to interface the ThingSpeak to AESP8266. And you're going to link that to STM32F411, and also you can interface to an ADC, and you can connect the pod to the ADC. That's what we're going to do in this project. Also, simultaneously, you can connect to a relay, and you can control the intensity of the light, and that will record the intensity. So this is the simplified block diagram to use your IoT. And as usual, you learned all this USART and UART parameters from the USART session, but the baud rate that we're going to use here in this project is 115200, and the data bit is 8-bit. It also has a parity bit on and off, and the stop bits, and it is a flow control. And these are all the AT commands that we will be learning to program from scratch. And these commands, you got to send it to your ESP8266 Wi-Fi module, and you have to set your Wi-Fi name and your password, and then link that to the ThingSpeak IP. So this is the ThingSpeak IP, and the 80 is the port number. So you got to key in all this in the coding, which you will learn shortly. As I said, the connection details, we're going to use USART 1, which is PB6 and 7. PB6 and 7. As you can see, PB6 is connected to USART 1 TX, PB7 is connected to USART 1 RX. And as you can see from this nucleo board pin diagrams, you can see PB7 is pin 21 here on connector 7, and PB6 will be on connector 10 pin 17. So you got to connect these two pins. These are all the slide that I copied from the user transmit that when we learned. So there we used a PA2 and PA3. We are not going to use port A, we are going to use port B. So instead of just set PA2, PA3, you have to set PB6 and PB7. And the alternate function is F07. So you got to follow all these steps to communicate via the USART. And this is the block diagram. We're going to use the USART 1, and that's connected to APB2, and the APB2 is connected to the bus, and the bus is connected to the microcontroller. So we're going to use GPIO over port B, and that GPIO over port B is connected to AHP. So you got to enable both the clock for port B and the USART. So this is the functional mapping as we just briefly learned. We're going to use USART1, and these are all the two registers that we're going to use, USART1TX and USART1RX. Functional mapping, as we just discussed, these are all the functional mapping. And the alternate functions, you got to use AF07. So here it will be 0. You're going to this one is showed with the previous example PA2, PA3. This is for PA2, but we got to use PB7, so which will be here, AF07, AF7. So this is used for AF2, 0, 1, 2. This is AF7, so 0, 1, 1, 1. You're going to use bits 31, 30, 29, and 28. And you got to do some calculations to get your baud rate. As we already learned about peripheral clock, it's 16 megahertz. And if you want to use a 9600 baud rate, this is the hex value you got to implement. And today's example, in today's project, we're going to use ESP8266 that runs on this baud rate, 115200. If you put that in the calculation, you will get the BRR 139, and the hex value of the BRR is 008B. So this is what you're going to code in. And this is the program to show USART write. As you know, you got to wait until the data register is empty, and you just link that to the data register with setting that bit as 1. So if that bit is 1, data is transferred to the shift register. If this bit is 0, then that means it is not transferred to the shift register. And this is about the USART data register. It's value 8 to 0, and we're going to use the address offset 0 cross 04 to transmit. And the connection details you saw from the previous slides, and this one we are not going to use the relay in this project. We're going to use the port meter and connect the ADC. As the port value changes, you would be seeing the value in IoT ThingSpeak. So this is how a typical ThingSpeak home page will look like. When you go into thingspeak.com, and after you created your login page and after you entered your credentials, you will see a screen like this, signed in successfully, and you will start with the channels. You can create up to 8 free channels. Anything after that, 8 channels, you need to pay to be a subscriber, but 8 channels is all you need for a starter. And you can set simply the 8 channel to whatever sensors you're going to create or link it to. For example, this is field 2 is a temperature sensor, and field 3 is set as a distance sensor. Like if you're walking, and if you got your smart watches, and you can also link that data to ThingSpeak as well. So this is how you have to create the channel. And once you created the channel, and this is just example that I showed with the help of Pantech Solutions. They were happy to show me for demo, so I got this to just show this to you. So once you created the channel, you would be able to see this value in the form of charts. So you link that to MATLAB and you can do more analysis. And this is very important. When you are in the channel, you need to go to API keys, and you need to get the right API key and read API key. You need this both keys. You got to transmit to read a data and write a data. You need both these keys. So after you create the ThingSpeak channel, you need to go there and copy these 2 keys and keep it handy. We'll be needing this in the program. So this is the location where you go write a channel, and you need to include that there, and read a channel, you need to include it there. Okay, that's enough of knowing about this project, and I think it's getting a little bit longer, so I'll leave you to go and have a short break. When you come back, let's get into opening the IDE and start creating this project, and I'll show you line by line from scratch how to write this program. and you're going to see the output in the ThingSpeak cloud. So please go and enjoy that break, and I'll see you back here shortly. See you then.